Another example for the chain rule. We want to find g prime of x if g prime of x is equal to 4x to the fourth minus 4 all to the fifth times 6x squared plus 12 to the ninth power. Here we're going to use the product rule combined with the chain rule. So just a reminder, with the product rule, if you have the function f times g, then the derivative of the product of these functions is the first function times the derivative of the second plus the derivative of the first function times the second function. So we want to find the derivative of, let's say this is f and this is g. So let's say that f is equal to 4x to the fourth minus 4 all to the fifth. That will give us f prime is equal to, we're going to use the chain rule here similar to the previous example. So we will have 5 times 4x to the fourth power minus 4 intact to the 5 minus 1 is 4 times the derivative of the inner function. In this case, it is 16x cubed. So that is f prime of x. And then we're going to say that g is equal to 6x squared plus 12 to the ninth power, which means g prime is equal to 9 comes down 6x squared plus 12 intact to the eighth power times the derivative of the inner function, which is in this case 12x plus 0. So we have the function f, its derivative, the function g, its derivative. We're going to apply it to this formula. So the derivative of g is basically the first function times the derivative of the second function. I treated this part as f and that part as g. And notice how I used the chain rule for each one of them. I know this basic rule from previous examples, so I can apply it to a more complicated concept. F is 4x to the fourth power minus 4 to the fifth times the derivative of g is 9 times 12x is 108x times 6x squared plus 12 raised to the eighth power. So I'm going to plug it here. 108x times 6x squared plus 12 raised to the eighth power plus f prime, which is that expression. 5 times 16 is 80x cubed. 5 times 16, x cubed is 80x cubed times 4x to the fourth minus 4 to the fourth power. This is f prime times the function g, which is 6x squared plus 12 to the ninth power. So I'm going to simplify these expressions a little bit. I'm going to bring this to the very front, so I will have 108x times the first expression, 4x to the fourth minus 4 all to the fifth times the second expression, 6x squared plus 12 all to the eighth power, plus this is of course g prime of x, 80x to the third times 4x to the fourth power minus 4 all to the fourth power times 6x to the second power plus 12 all to the ninth power. Now I can bring 4x to the fourth power minus 4 to the fourth power out as a common factor because I have one here, and I can bring 6x squared plus 12 to the eighth power outside because I have another one like that. I can also bring x out or 4x out. So if I do that, I will have 4x out, and then I will bring 4x to the fourth minus 4 to the fourth times 6x squared plus 12 to the eighth power, and then the remaining is 27, and then we have 4x to the fourth minus 4 remaining from the first expression, and then from the second expression we will have 20x squared remaining, and we will have 6x squared plus 12. This will give us 4x to the fourth minus 7 to the fourth minus 4, sorry, to the fourth times 6x squared plus 12 to the eighth, and then we will have that expression to simplify, which will give us 108 x to the fourth minus 108 plus 20 times 6 x to the fourth plus 20 times 12, 240x squared. Let's see if we can combine any of these terms together. I notice that I have 120 to the fourth and 108 to the fourth. I can combine those two. So that will be 4x times 4x to the fourth minus 4 to the fourth power times 6x squared plus 12 to the 8th power times 228 x to the fourth plus 240x squared minus 108. And that would be the final answer. I'm not going to bother by simplifying this any further. This is the final answer for that question. So I could have actually left it in this form instead of trying to simplify it further, but this is the simplification of it. I don't think this algebra is necessary in this case. So if you're required to differentiate a function that looks like that, then that would be enough, and that would be the final answer for that.